this video, I'm going to cover a math topic you might see on the ACT exam called function translations. Now, one translation we can do to a function is shift it up or shift it down. When we want to shift something up, we just simply add that number to the function. So in this case, we add 2 to f of x. It's going to shift the function up by 2. That basically moves every single y point up by 2 coordinates. Okay, if I subtract 3, I'm going to move the whole function down by 3. So every y value of the function would decrease by 3, shifting the whole graph down by 3 units. So for example, if I had the function f of x equals x to the third, if I want to shift it up by 2, I would change it to x to the third power plus 2. If I want to shift it down, I would make it x to the third minus 3. So that's how you translate the graph up or down. Look at an example. The red is x to the third. Okay, that goes right through the origin. The blue is x to the third plus 2. So we can see that every point is shifted up by 2. It used to go through 0, 0, but now it's going through 0, 2. And then the green line is x to the third minus 3. So it's shifted down by 3. So now its x-intercept is at 0, negative 3. Now let's talk about horizontal translations. So if I have my function, now if I change the x value directly, x plus 2, that's going to shift it to the left. Now if I do f of x minus 3, it's actually going to shift it 3 units to the right. So the first one shifted to left by 2 units. The second one is shifting to the right by 3. Now it might seem kind of opposite, so if it's adding, it's moving it to the left. If it's subtracting, it's moving it to the right. So for example, if I have x to the third power, if I do x plus 2 raised to the third power, that's going to shift it to the left by 2. And if I do x minus 3 raised to the third power, it's going to shift it to the right by 3. So we can look at that. So the red is x to the third. That goes through the origin. The blue is x plus 2 raised to the third power. And we can see that's to the left of the red line. And the x-intercept goes through negative 2 instead of 0. And we can see the green line, x minus 3 raised to the third power. You can see that it's shift to the right compared to the red line. And now the x-intercept goes through 3, 0. Now you can also reflect about the x-axis. So I have my function f of x. And if I make that negative f of x, that basically changes the sign on the y coordinates of the points. So if I had positive 2 for my y, now it'll end up being negative 2. I had negative 5 for my y value, now it would be positive 5. So basically going to flip it over the x-axis. If it was on top of the x-axis, it would move below it. If it was below the x-axis, it would move above it. So for example, if I have my function f of x equals x squared, to reflect it about the x-axis, I'm going to make it f of x equals negative x squared. So I'm basically going to change the sign on my y values. So we see here the red is x squared. So we have a parabola and it's opening upward. If we have negative x squared, it's going to flip it over the x-axis and now it's going to be pointing downward. So we can see if any point here is now going to move down to the other side. It's going to flip the sign on your y values. We can also reflect about the y-axis. So if it was on the left side, you can move to the right side. If it's on the right side of the y-axis, you can move to the left side. So we have our function f of x. So we change the sign on the x, so now it's f of negative x. That's going to move our x values to the other side of the y-axis. So for example, if I have f of x equals x to the third, I'm going to change it to negative x raised to the third power. So like I said, that's going to reflect it about the y-axis. Move it to the left side of the y-axis or to the right side, depending on the sign of the x. So here we have in red x to the third power, and in blue negative x to the third power. So we can see here, if any point was over here, now it's over here. Likewise, if it was over here, now it's over here. So switch sides of the y-axis. So we talked about shifting the graph up and down. It's just adding some constant value to the function. So you're going to either add something to the y value or subtract something from the y value. And we talked about shifting left or right. So if you add something to the x, it's going to move it to the left. If you subtract something from the x, it's going to move it to the right. Now you can have a combination of those shifts. So you can reflect it, you can shift it up or down, left or right. You have any kind of combination of those translations. So we look here, the red is x squared. That's our parabola, red parabola. Now our blue, you can see there's several translations that occurred here. So I have the negative out front. The plus 3 is going to add 3 to the y values. So you can see that the graph is flipped upside down and moved up. Alright, so this is an example ACT problem, and it reads, in a standard xy coordinate plane, given parabola A with equation y equals negative 2x squared, parabola B is the image of parabola A after a shift of 5 coordinates to the left and 3 units down. Parabola B has which of the following equations? Okay, so we're starting out with y equals negative 2x squared. If we want to shift it to the left by 5, I need to change the x. And when you say to the left, we need to add. So we're going to add 5. Alright, so that's our shift to the left. And if we want to shift it down by 3 units, we need to subtract. So we're going to subtract 3. So our new function for parabola B is going to be negative 2, the quantity x plus 5 squared minus 3. And this one reads, in a standard xy coordinate plane, the coordinates of the y-intercept of the graph of the function y equals f of x are 0, negative 3. What are the coordinates of the y-intercept of the graph of the function y equals f of x plus 5? Okay, so we know when we just add 5 to the function, that's going to shift the graph up by 5. So we have our current graph where our y-intercept is at 0, negative 3. So all we're going to do here is move our point up by 5. So we got 1, 2, 3, 4, 5. Okay, so we're at 0, positive 2. So we basically did negative 3 plus 5 to give us positive 2. So our intercept is going to be at 0, positive 2. So answer B. So I hope this video helped you understand function translations. You can translate the graph up by a certain amount, you can translate it down by a certain amount, you can translate it to the left, you can translate it to the right, you can reflect it about the x-axis, and you can reflect it about the y-axis.